Twitter. WhatsApp is 082-654-2446. Just drive and arrive alive.
Do you have any traffic update? Tweet us at Capricorn FM or WhatsApp 082-654-2446 and hashtag Limpopo Traffic.
This lesson is proudly brought to you by Kagiso Trust in partnership with the Limpopo Department of Education and Capricorn FM. Kagiso Trust, overcoming poverty.
It's 5:05, Capricorn FM, Limpopo's hottest frequency. Of course, the time we've been waiting for. Hashtag Kagiso Radio Teacher. Class is in session. All right. Super excited about this one. So if you are matriculant, just drive. These are lucky times for you. So you can quickly just holler at your friends, let them know what the class is in session. Today we're taking a look at physical science Term 1, Momentum and Impulse. Now, I did physical science in high school.
You did?
Yes, I did. I did mathematics. Well, I did physical science.
Yeah.
Momentum and impulse is new.
Oh.
No, it's new to me. I'm not going to lie. Right? I did speed, velocity,
At least you still remember some of the things you did back then.
Some of the stuff. So joining us today for today's lesson at Physical Science Term 1, Momentum and Impulse, Mr. Tangwane. On Capricorn FM Just Drive. Tobela. Yeah, no, you can speak on the microphone.
Okay.
Yeah. You can also tell us or kilena bumang le jwale le kae and lona le ruta subject efe lona le ruta sekolo se sefe.
Then le tlatla le thoma.
Le tlatsa nang kara lesson.
I am Tangwana Tanyani Lodwick Akazex. I am from Leshavana High School in Vembe.
Nice.
I'm here to present a lesson based on momentum and impulse. Good evening, dear grade 12 physical sciences learners and parents. I am here to present a physical sciences lesson based on momentum and impulse. Are you ready? Let's start. Momentum in physics is defined as the product of an object's mass and its velocity. Mass is the quantity of matter in the body. It is a scalar quantity measured in kilograms. A scalar quantity has only magnitude, that is size. Velocity is defined as the rate of change in displacement. It is a vector quantity measured in meters per second. It has both magnitude and direction. Momentum is a vector quantity whose direction is that of the velocity of the object. The symbol for momentum is a lowercase p, that is small letter p. We then have the definitional formula for momentum, which is P equals mv, that is mass times velocity. In the international system of units, momentum is expressed in kilograms, meters per second. Kilograms, meters per second. In writing the units, be very careful. Don't use full stops. Kilogram, a multiplication dot, meter, multiplication dot per second. When writing the formula for momentum, ensure that P is a small letter. The question is, How can one distinguish between a small letter and a capital letter? Okay, for a small letter, the head of the letter is in line with the equal signs. We can deduce from the equation of momentum, namely P equals mv, that P is directly proportional to V with m constant. That is, momentum is directly proportional to velocity when the mass is constant. And B, note well, whatever happens to velocity, the same will happen to momentum. For example, if the velocity of an object doubles, then the momentum of the object doubles also. And momentum versus time graphs have the same shape as the velocity versus time graphs. Momentum must not be confused with inertia. All massive objects have inertia, even though they are motionless. Massive objects possess momentum only when they are in motion. Let us take this exam type question. Activity 1. Calculate the linear momentum of a 1350 kilogram car, a 1350 kilogram car, that is 1,350 kilograms, moving northwards at 26,39 meters per second. 4 marks. Calculate the linear momentum of a 1350 kilogram car moving northwards at 26,39 meters per second. 4 marks. Let us solve this together. For scientific calculations, we use the LPWC approach. 1. L for love. 2. P for physics. 3. W for width. 4. C for chemistry. So love, physics with chemistry. We are going to consider the first letters. As already stated, LPWC. Step 1, list known information. Give the values of the quantities known from problem statement. In this case, we have M, which equals 1350 kilograms. We have V, which equals 26,39 meters per second. Identify the target, that is the unknown variable, which in our case is P, that is momentum. Step 2, P for pick from physics. Pick your relation, that is, pick your equation. The correct equation earns you a mark before you reach for your calculator. Write down the formula for momentum. That is, P equals mv. Step 3, W, write down the known values into the equation. This is the remove and replace step. We substitute for mass and velocity in the equation. Therefore, we have P equals, open bracket, 1350, close bracket, open bracket, 26,389, close bracket. P equals, we remove M and replace it by 1350. We remove V, we replace it by 26,9, which gives us 35,626,50 kilogram meters per second. It is essential to keep in mind the directional character of linear momentum. Remember, P is a vector quantity, therefore, direction must be stated along with the final answer. We eventually have P equals 35,626,50 kilograms meters per second northwards. That is the direction, northwards, to the north. Step 4, from chemistry, we have check that the answer is reasonable with full specification. Excellent. The units are correct and the direction is clearly stated. Newton's second law of motion in terms of momentum states that the net or resultant force acting on an object is equal to the rate of change in or of momentum of the object is equal to the rate of change in or of momentum of the object. Don't worry about the prepositions in and of. They are almost the same. Open bracket, and this change is in the direction of the net force, close bracket. This is the way it is written in the exam guidelines. And this change is in the direction of the net force. But it is not necessary to include the information in bracket. Why? In that equal vectors have the same magnitudes and same direction. In symbol form, we have capital letter F and a subscript net, that is F net, the net force, equals delta P divided by delta T. Delta P divided by delta T, in which case delta P divided by delta T is the rate of change in momentum. The net force is measured in newtons. Therefore, the rate of change in momentum is measured in newtons also. Right. Delta P, that is change in momentum, equals PF minus PI. Small letter P, subscript F for final momentum, minus small letter p, subscript I for initial momentum. But momentum is mv. Therefore, our delta P equals mv final minus and V initial. Taking out a common factor M, we have delta P equals M open bracket V final minus V initial close bracket. M open bracket V final minus V initial. Okay, let us check activity number 2. A snooker ball with a mass of 170 grams. A snooker ball with a mass of 170 grams hits the cushion of a snooker table perpendicularly. Hits the cushion of a snooker table perpendicularly at 0.50 meters per second. At 0.50 meters per second, and rebounds to the west. And rebounds to the west at 0.40 meters per second. Full stop. The first question, 2.1, define in words the term momentum as applied in physics. 2 marks. Define in words the term momentum as applied in physics. 2 marks. 2.2, calculate the change in momentum that the snooker ball undergoes. Calculate the change in momentum that the snooker ball undergoes. 5 marks. 2.3, draw a labeled vector diagram. Draw a labeled vector diagram, not to scale, to illustrate the relationship among Pi, Pf, and delta P for the snooker ball. Among Pi, the initial momentum, Pf, the final momentum, and the delta P, the change in momentum for the snooker ball. 3 marks. Let us answer the questions together. Let us answer the questions together. 2.1, as written in the CAPS document and the exam guidelines, the product of the object's mass and its velocity. You are advised to use definitions from the exam guidelines and the CAPS document. Verbatim is recommended in this case and similar cases. 2.2, revisit activity 1 for LPWC approach. Recall the first commandment in physics. Recall the first commandment in physics calculations regarding vectors. Thou shalt make a sign convention. Thou shalt make a sign convention. That is, assign one direction a positive sign. You take one direction as positive. In this case, take to the right. Take to the right, that is towards the cushion, as the positive direction. Step 1, L. List the data as follows. Vi equals 0.5 meters per second. Vi equals 0.5 meters per second. Vf equals, don't forget the sign convention, To the right is positive. VI is positive 0.5. VF, the final velocity, is in the opposite direction, that is to the left. VF equals negative 0.4 meters per second. Our mass M equals 170 grams. 170 grams. But it is not allowed in this case for us to use grams. So we must convert grams into kilograms. Okay, 170 divided by 1,000 gives us 0.17 kilograms. 0.17 kilograms. The problem is, why are we dividing 170 by 1,000, not by 100, to convert grams to kilograms? The response is simple. The response is simple. Write down the following conversion medicinal statement. Write down the following convention medicinal statement. It reads, King Henry died a miserable death caused by malaria. King Henry died a miserable death caused by malaria. Underneath King, write capital letter K, a small letter K, not capital letter. Underneath Henry, write capital letter H. Underneath died, capital letter D. Underneath miserable, small letter M. Death, small letter D. Caused, small letter C. Malaria, small letter M. But because we're dealing with mass here, we want to convert grams into kilograms. Underneath K, write kg, kilogram. Capital letter H, hg, hectagrams. Capital letter D, dg, decagrams. Under M we have G, there grams. D for decigrams. C for centigrams. M for milligrams. Underneath each, that is kg, hg, dgg, dg, cg, mg, as you have already written, write 10 by 10 by 10 by 10 by 10 by 10 by 10. Ensure that the 10 is under the unit milligram. Underneath 10, centigram 10, decigram 10, gram 10, decagram 10, hectagram 10, kilogram 10. Cover the 10 underneath gram with your finger. Cover it with your finger. You obfuscate, right? Consider the left side of the finger, right? Multiply the tens from DG, from G, DG to KG. Look, you have covered G there, the 10 under G. Now you are left with DG, HG, and a KG. And if you check on your left, you have got 10 times 10 times 10. What does that give? It gives 1,000. Therefore, 1,000 grams equals 1 kilogram. We are breaking now.
Yeah, we're taking a small break. Yeah, I'm in class. It's 21, around 29 minutes after 5. Nhlamulo Marula is here with your news headlines. With Capricorn FM Sports.
Progressive Talk.
You know, we spoke about a similar case last week, MEC. And at that time, the other thing that I did think was, while you discover this case and you discovered the other last week, so it may seem that there are such cases in the province, One cannot tell how many of them, of course. But are there means, is this an eye-opener to say, let's start looking for cases like this and start working on this, maybe prioritize such situations?
Yeah, and I can say I have already seen, since I went to the one in Globek, many are coming and showing me to say, thanks for the intervention in that area. But look at the situation here. Look at the situation. They are many. What I have done up to so far, I have met with the people who are heading CW program in the department.
Progressive Talk with Ngamula Chauke, Monday to Thursday, 6 to 8 p.m. on Capricorn FM. Africa. Capricorn FM celebrates a continent like no other. Happy Africa Month from Limpopo's hottest frequency. News headlines on Capricorn FM.
In our headlines, hundreds of people who were turned away by the police have expressed dissatisfaction with the service at SASSA offices in Polokwane. Meanwhile, the Minister of Human Settlements, Water and Sanitation, Lindiwe Sisulu, has committed to attending to matters of alleged corruption in her department. And President Cyril Ramaphosa will address the nation this evening at 8:30. Your final bulletin at 6 p.m.
Capricorn FM Sports, on and off the field. We've got you covered.
Councillor Spanisha just drive kasi gimeta somtlango sukrana montlha kulang tisali sungela komeleleni. South Korean golfer Park Seung-hyun says she is pleased and also proud of the fact that South Korea is leading the way for the resumption of sports at a pre-tournament press conference in Gyeonggi province. The world number 3 Park Seung-hyun will feature in a star-studded field, even though she has yet to play in a competitive round this year. The 26-year-old's plan was to begin her US LPGA season in March, but it all went twisted when the tour was put on hold in February due to the coronavirus outbreak. But she is itching to begin her first tournament of 2020. And for safety reasons, the tournament will be played without fans, with world number 6 Kim Se-young expressing how it was a shame that she will not get to play in front of spectators, adding that she is still grateful that they are able to play at this tournament at all. And coming to football, Kaizer Chiefs chairman Kagiso Trust has named the late Patrick Ace Ntolengwe as his best signing since the club's inception. Amakosi turned 50 years old this year, which is half century since its formation on the 7th January 1970. And the club continues to commemorate the special achievement throughout the year. And Capricorn FM Sports reporter Vusani Moyo has the details.
Motaung has been the cornerstone in the success of the Glamour Boys, and his integral role to this has been bringing some of the most enterprising and talented players to steer the team to glory. Some of those special talents who have donned the black and gold over the years include the likes of Dr. Khumalo, Max Maponyane, Teenage Dladla, Neil Tovi, Lucas Khatebe, Fani Matita, Arthur Zwane, and many others. While in recent times, Amakosi has also brought in the talents of the likes of Simpiwe Chabalala, Renelwe Letsulonyane, Tefuma Shamaite, and Willard Katsande, all of whom have achieved a substantial amount of success for the Soweto Giants. However, according to Chincha Guluva himself through the club's official website, it would seem none of these come close to being Chiefs' all-time best signing. Patrick Ace Ntoleng remains the best signing for the chairman, adding that he was a special player. And for Capricorn FM Sport, I'm Vusani Moyo.
And lastly, former Dolphins coach Grant Morgan has expressed how Proteas spinner Keshav Maharaj has the right ingredient for leadership. Morgan spent 3 seasons as head coach of the Dolphins from 2016 to 2019 until joining the Scotland national side as an assistant coach. Morgan remembers the 30-year-old being a strong leadership figure in the squad, as there were several instances where Maharaj had to captain. The 48-year-old believes that anyone who wants to lead should be encouraged to do so, even though there are other options for the test captaincy like Temba Bavuma, Aiden Macrom, Dean Elgar, and Resi van der Deysen. Meanwhile, the Dolphins landed one Day Cup trophy this season under Maharaj, even if that competition was cut short by the coronavirus crisis. For more updates, do follow us on Twitter at Capricorn FM News. For Capricorn FM Sports, I am Mahlatse Mogale Riperila.
Keeping you up to date with the latest sports news. Capricorn FM Sports.
This lesson is proudly brought to you by Kagiso Trust in partnership with the Limpopo Department of Education and Capricorn FM. Kagiso Trust, overcoming poverty.
We continue with Mr. Tangwana in the studio with us. We're talking physical science, momentum and impulse, term 1. We can continue, sir.
Let us continue with our convention medicinal statement. 1,000 grams equals 1 kilogram. Therefore, 170 grams equals X. Let us solve for X by cross multiplication. We have X equals 170 divided by 1,000. 170 divided by 1,000, which gives us 0.17 kilograms. Step 2, pick an equation. Write down delta P equals M, open bracket, VF minus VI, close bracket, or delta P equals MV final minus MV initial. Step 3, write down the known values into the equation. Therefore, delta P equals, remove M by 0.17, open bracket, we have got 0.17, close bracket, open bracket, remove VF by negative 0.4, minus, remove VI by 0.5, close bracket. From a calculator, we therefore get delta P equals negative 0.153 kilograms meters per second. Delta P equals negative 0.153 kilograms meters per second. The negative sign indicates the direction. That is away from the cushion. That is to the left. That is to the west. The second physics commandment, thou shalt paraphrase. Thou shalt paraphrase. Therefore, the change in momentum delta P is, therefore, the change in momentum delta P is 0.153 kilograms meters per second to the left. Therefore, the change in momentum delta P is 0.153 kilograms meters per second to the left. Step 4, check that the answer is reasonable with full specifications. Indeed, a reasonable magnitude, correct units, and a clearly stated direction. 2.3, refer to the receipt given earlier. Refer to the receipt given earlier. Here follows the receipt. Step 1, draw a big enough dot in the middle of the page. Draw a big enough dot in the middle of the page. You do have the dot in the middle of the page, right? Okay. Step 2, draw PI vector starting from the dot. This is a west pointing arrow. Draw PI vector starting from the dot. This is a west pointing arrow. You do have the arrow ready, right? Draw PF vector also starting from the dot. This is an east pointing arrow. Draw PF vector also starting from the dot. This is an east pointing arrow. Step 3, draw delta P vector starting from the head of PF to the head of, starting from the head of PI, that is the initial momentum, to the head of PF, that is the final momentum. You now have a full diagram. Look at it. Delta P has the same length as PF and PI, isn't it? Write down the defining equation of acceleration. That is A equals delta V over delta T. A equals delta V over delta T. Mark it equation 1. A equals delta V over delta T. Mark it equation 1. Right? Write down the equation of Newton's second law of motion in terms of acceleration. F net equals ma. Capital letter F, the subscript net, equals ma. That is mass times acceleration. Mark it equation 2. We have 2 equations now. Substitute equation 1 into equation 2. We substitute 1 into 2. We therefore have F net equals m dot. That is the multiplication dot, not full stop. Dot delta V over delta T. This gives us F net equals m delta V, that is the numerator, m delta V, divide by delta T, the denominator. Right? Therefore, the mathematical statement of Newton's second law of motion in terms of momentum is, we now have the mathematical statement, F net equals delta P over delta T. In words, it states that the net force acting on an object is, it states that the net force acting on an object is equal to the rate of change in momentum. Equal to the rate of change in momentum. Again, worry not about the prepositions. You can use in or off. They are almost the same. Okay? Right. To set an object in motion from rest, a non-zero net force must be applied for a period of time. We might expect that the greater the force and the longer the time, the more the momentum the body will have. This expectation is correct, and the product F net delta T is accordingly given the status of a physical quantity in its own right. This quantity is called impulse. Therefore, we have impulse equals F net delta T. Impulse in physics is defined as the product of the resultant or net force. Resultant or net force acting on an object and the time the resultant or net force acts on an object. Don't write resultant or net in the exam. No. Take one. You choose one. The choice is on your shoulders. From F net equals M delta V divided by delta T, we have F net delta T equals delta P, where F net delta T equals impulse and delta P equals change in momentum. Impulse is a vector quantity and the SI units are Newton second, capital letter N, multiplication dot small letter s. Impulse is always in the direction of the net force. F net delta T equals delta P is known as the impulse linear momentum theorem. Impulse linear momentum theorem. The above theorem can be used to calculate the 1. Average net force exerted, 2. Time for which the net force is applied, 3. Change in momentum for variety of situations involving the motion of an object in one dimension. The impulse linear momentum theorem states that when a net force acts on an object, the impulse of the net force is equal to the change in momentum of the object. The impulse of the net force is equal to the change in momentum of the object. The same change in momentum may be the result of 1. Large force exerted for a short time. 2. Small force exerted for a long time. Exercise. Let us take this exercise, a very short activity, which of course is the application of the impulse and the change in momentum. The question is as follows. A boxer being hit with a punch contrives to extend time for best results, whereas a karate expert delivers a force in a short time for best results. Isn't there a contradiction here? State only yes or no and justify the answer. Let us respond to the question. Our choice of answer is no. Let us justify. There is no contradiction because the best results for each are quite different. The best result for the boxer is reduced force, accompanied by maximizing time. And the best result for the karate expert is increased force delivered in minimum time. Let's check the application further. F net equals delta P divided by delta T. Airbags, the seat belts, and the crumple zones are used in cars to increase the time it takes for passengers or vehicles to stop during a collision, the passengers will experience the same change in momentum, but if the time to stop is increased, then the force experienced decreases. As F net is inversely proportional to time and delta P is constant. And B, all safety features in modern cars are meant to increase the contact time during collision, which reduces the impact of force on the driver or passengers or vehicles, thereby protecting them from fatal injuries or death or damage. Conservation of linear momentum and elastic and inelastic collisions. The law of conservation of linear momentum states that the total linear momentum of an isolated system remains constant. Okay, trying to give the statement of the law, we have the term closed system. We have the term isolated system. What is this isolated system in physics? A closed or an isolated system in physics is one on which the net or resultant external force is zero. One on which the net or resultant external force is zero. An isolated system excludes external forces that originate outside the colliding bodies, e.g., friction. Only internal forces, e.g., contact forces between the colliding objects, are considered. Let us now distinguish between external forces and internal forces. External forces are forces exerted on the objects by agents external to the system. External forces are forces exerted on the objects by agents external to the system, whereas internal forces are forces that the objects within the system exert on each other. The term system frequenting here is a small part of the universe that we are considering when solving a particular problem. Let us state the law of conservation of linear momentum. The second statement, which is equivalently correct, is in a closed or in an isolated system, the total linear momentum before a collision is equal to the total linear momentum after the collision. The total linear momentum before a collision is equal to the total linear momentum after the collision. It is inappropriate to write the total linear momentum of a closed or an isolated system remains constant or is conserved in both magnitude and direction. In both magnitude and direction. This statement, as written with the words in both magnitude and direction, is tautologous. Momentum is a vector quantity. It is constant when both magnitude and direction are maintained. Consequently, write the law or principle as written in the exam guidelines. For calculation purposes, write the summation sign, the sigma notation. Pi, that is the total initial momentum, equals the summation sign, the sigma notation, Pf, that is the total final momentum. Summation sign Pi, the sum of all the momenta before, equals the sum of all the momenta after. And B, practice writing the symbol, because some write an E instead of the summation sign. A conserved quantity is one that remains unchanged, one that remains constant, one that remains the same as time passes. During a collision, the forces that the two objects exert on each other are equal in magnitude and opposite in direction. This is in keeping with Newton's third law of motion. Once you kick, you are kicked. Once you touch, you are touched. These two equal and opposite forces are exerted simultaneously on two different bodies. Thus, they cannot cancel each other out. Problems involving conservation of linear momentum in collisions. The generic subscripts I, the lowercase I, small letter I, F, lowercase f, small letter f, for initial and final are adequate in physics equations. 1. The general form of the equation to use is, M1 V1I plus M2 V2I. Remember, the 1, 1 and I, the 2, 2 and I are subscripts. Equals M1 V1F plus M2 V2F. Mark it equation 1. There you are. 2. If an object is at rest before the collision, its initial momentum Vi equals 0. 3. If both objects are at rest before the collision, e.g., gun and bullet, their combined initial momentum is 0. So equation 1 becomes, open bracket, M1 plus M2 close bracket, Vi, open bracket, M1 plus M2 close bracket times by Vi equals M1 V1F plus M2 V2F. Mark it equation 2. 4. If an object is brought to a complete standstill, to rest, to a halt, V final equals 0. 5. If objects are coupled, if objects are joined together, if objects are united after the collision, their final velocities are equal. That is, V1F equals V2F equals VF. And the equation 1 becomes M1 V1I plus M2 V2I equals, open bracket, M1 plus M2 close bracket times VF. Mark it equation 3. This equation can also be used for an object falling vertically onto another object moving horizontal, but the falling object's initial horizontal velocity is 0. Note well. And B, objects at rest have 0 momenta because they have 0 velocities.
Yes, I think that is our time. That is our time. Thank you so much, Troy. Fisher.
I can imagine.
But,
No, you still wanted to go on. Unfortunately, that is the time we have for today. But thank you so much for coming.
okay.
We really appreciate it. It means a lot. Hashtag Kagiso Radio Teacher. I hope you did grasp something from that. We're going to be doing this every single day. So tomorrow, of course, we're going to be having another educator that's going to be joining us from 5 o'clock all the way up until 6. Myself and Itubanda are calling it a wrap. Thank you so much for tuning in. We're making way for Ngamala Chauke on Progressive Talk. He's hanging out with you up until 6 p.m. Righty, Dinko Muntu.